needs to be added to CloudStack. And people all wanted to do different things. At layer 2, you want to do physical, VLAN, layer 3, overlays, SDN, right? Quality of service, traffic monitoring. This is a lot of things you want to add at each layer. Layer 3, public IP address, gateways, VPNs, firewalls. Layer 4 has been security groups. Layer 7, load balancing. There's a lot, and there's going to be more to come because people want different ways to control the network. So the key for CloudStack is that we do not control this innovation. The key is that we only do our part and let other people innovate within CloudStack. So to enable this innovation, like I said, we cannot define the innovation. And the partners define their own APIs. The partner and CloudStack can work together on a unified API through design process on Apache. So say, for example, today we introduced auto-scaling, which only works for NetScaler. And they present that as their own API today. But then they can submit that to CloudStack, Apache, and says, I want everyone else to also be able to use this. And they can utilize that API. And we can design that through Apache's processes. It was very important that we differentiate between orchestration and provisioning. And CloudStack only orchestrates. CloudStack doesn't actually do the provisioning. And I think that might be obvious from my talk a little bit earlier. Provisioning is always pushed to the partner because CloudStack doesn't understand how to do this provision. And then we wanted to clearly define a data center abstraction layer. Changes in this layer are then broadcast to the partners. So when I'll explain that a little bit later. And then utilize the CloudStack's orchestration to deploy and auto-scale partners' technologies. So let's take a look at the CloudStack's terminologies. As for the end user, we have the concept of network. This is one concept to encapsulate a lot of different network technologies. Because to the end user, they don't really need to understand the technology underneath. But they need to understand that, the VMs are actually attached to a network. So I always call this one network to boot them all, one network to define them, one network to bring them all in the cloud and bind them. So I'm not sure if that translates well, but that's from Lord of the Rings, and it's about one ring to rule them all. Each network always carries the network traffic type that is on. And then CloudStack doesn't understand how to provision the conceptual network onto the physical network. And then to the end user, we also provide the idea of network service. They see the fact that they have a load balancing service. They see the fact that they have a load balancing rules and things, and DHCP and DNS. But they don't understand how it's implemented underneath. And so in the definition, we currently have load balancing, port forwarding, firewall, gateway, DNS, DHCP, static NAT, VPN, source NAT, user data. And then all these network services are packaged into network offerings. So the end user, what they will see, for example, is a high data network, high-speed data network with high-speed load balancing. But they may not understand that the load balancing is actually provided by a NetScaler instead of our VPX. And then what they see is a normal network, and the normal network is actually load balancing is provided by CloudStack's VPX. So that's a packaging to simplify the presentation to the end users. To the operator, CloudStack terminology, they have to define the network traffic types. So there's a difference between network traffic type and network, and people kind of get them mixed up because storage traffic type sounds just like storage network, but really it is not. In network traffic types, these are virtual concepts to CloudStack. They're concepts that says oh, I have this type of traffic, and I want you to map this traffic down to this set of network. So the actual network is underneath at the physical layer, and the traffic type is just the concept of what data is carried in that. So today we define public, guest, storage, and storage is misnamed because it's really not the. A lot of people take storage as the primary storage. It's really the backup traffic in CloudStack and the management traffic. But we expect what we expect people to do is actually add more types of traffic type into CloudStack and says this is how I map traffic type down to this particular physical network, so that people can actually include more types of traffic. It might be a monitoring traffic, or it might be the actual storage traffic in CloudStack. So to the operators, we introduced another term called network service provider. These are the partners that provide different types of network services in their network. So these are the plugins, but then they deploy the instances and then tells CloudStack to use that particular plugin to control that particular instance. And then there's the concept of physical network. This is the actual wiring of your data center. And then you can do in CloudStack a mapping from the network traffic type down to that physical network that says the network traffic, this type of traffic is carried by this particular network. And also how is it carried? Is it carried only using VLAN or some other means? And to our partners, then we introduced the ideas of network guru. And as I said earlier, network guru is a plugin that understands the network isolation technology, MAC addressing schemes, the IP addressing schemes, and how to map network traffic types down to underlying physical network. And CloudStack passes network to network guru to implement before the network is needed by the virtual machine. And CloudStack then asks the network guru to issue IP, MAC, and isolation to a virtual machine before it starts. CloudStack also informs the network guru when the virtual machine stops, so it can collect resources. I should say garbage collect resources. When all virtual machines in the network are stopped, then CloudStack will garbage collect the network itself by asking the network guru to shut down the network. CloudStack provides the default implementation for VLAN-based isolation technology. There's also a prototype for OVS. Someone has also added gurus for the Ceres implementation, and we expect others to add more in this area. So the network element is the interface that specifies the events that CloudStack signals to the network service providers. Remember, network service providers are the actual code that implements a network service. The network element interface, it just tells the service providers what events will happen, and tells you what information are carried with that event. So when the network needs to be implemented and shut down, and the virtual machine joins and leaves the network, each of them causes an event in CloudStack's orchestration, which then gets propagated to the network elements. So when I did this, one of the things that I was thinking about is that when you have this explosion of technology and technology providers, how would they work together? What makes sense? And what is really the role of CloudStack? And how do we come up with this role that CloudStack only does orchestration? And I'm not sure if this applies in Japan, but I'm going to kind of go over it. If there's questions, you can ask me. So the model that we came up with is very much like building a house. When we build a house in the United States, the builder offers multiple blueprints to the owner and says, oh, no, I have these blueprints to build this house. Which one do you choose? The owner chooses something that they want, and then they add on things like hardwood floors and granite countertops and any of the finished elements. And then there's a general contractor who builds to this blueprint. And this general contractor is there to orchestrate between the subcontractors. The subcontractors are the ones who actually does the work of building. And there are generally two types of contractors. There's the roughing subcontractors who builds framing, plumbing, electricity. And then there's the finished subcontractors who puts in flooring, puts up sheetrock, puts up kitchen cabinets. Each subcontractor is responsible for the work. But then they look over the entire blueprint to make sure the work can actually be done. So for example, if the owner says, I want a light at a certain area, then the electrician will look at it and says, well, you have a frame going through right there. So that needs to be moved. Because when they look at the blueprint, they go, well, this area, I cannot put the light right here because the opening is right at the frame. Same thing with plumbing. And the plumbing contractor needs to look at it and says, well, now I know this blueprint doesn't, the framing for this blueprint doesn't make sense because I cannot implement my plumbing and do the house like this. So then, and the general contractor is only responsible for sequencing the subcontractors, but the subcontractors needs to look at all the entire blueprints to make sure everything will work. And every change in this blueprint will be republished. So you make a change to the blueprint, you send the same blueprint to every single subcontractor and says, here's a change. You mark off the change, and you can take a look and make sure you can all identify what works for you and or not. So we come up with this model, and this model is very similar to how we build networks. The owner is the end user. He's the one who gets to choose what the builder has provided to him. And the builder is the cloud operator. He's the one who says, I'm going to make these network offerings and offer it to the end user. The general contractor is CloudStack, because CloudStack is doing orchestration. And the roughing subcontractors are basically network gurus because they are providing the underlying and network divisions. And the finished subcontractors, these guys provide the network services on top of the underneath framework. The blueprint is the network, and cabinets and floorings and countertops, things like that, are the different network services you provide to that particular network. So when you go through this, then you can kind of see CloudStack is doing the work of the general contractor. Its job is to tell the general, all the subcontractors, hey, this is your time to come in and work on this network. I provided the following things, and now you can come in and work on it. So CloudStack clearly defines the difference between orchestration and provision. And orchestration is the ordering of what needs to be happen in CloudStack's abstraction layer. So for example, in CloudStack, we say, if you want to provision a network rule, you better have the network ready when the network rule happens. Now, the network and the network rule are both CloudStack's abstractions. And what happens underneath, we don't know yet. But we know the network itself has to be ready before the network rule can be programmed. That's the difference. And provisioning is the actual work performed at the resource. So provisioning is when you actually implement that particular rule on the resource itself. CloudStack clearly defines the difference between network definition and network services. So this is where the difference between network guru and network element or network service provider is. Network guru defines the network service provider defines the service that you can provide inside that network. CloudStack broadcasts changes in the network every time network services and virtual machines change in the network. And then CloudStack allows the cloud operator to set up the appropriate mapping between the virtual concepts, such as network and network traffic type, to the underlying physical network. So for example, the network operator should be able to tell us, what I want to use is VLAN technology to isolate, or what I want to use is OVS technology to do isolation for the VMs. And CloudStack, let them do that setup, and then CloudStack orchestrates within those technologies. So I think, and actually this sequence diagram we went through before in the previous, so I'm not going to go through it again. This is basically the same startup sequence. So CloudStack's user APIs, you can, I wanted to give an example. For example, for network, you can create the network. It will require a network offering ID. Remember, network offering is a packaging of different network services. So you will tell, when you create the network, you will say, oh, I want to create a network with the following services on that particular network. The services are defined by the cloud operator, not by the end user, and offered as a package to the end user. You can delete the network. You can list the networks. You can restart a network. And what restarting a network means is that you need to reprogram all the rules that was in that network before. You can restart all of the devices because of restarting network. And then you can support, and what that does is restart the device, and then you reapply all the rules that were specified. And then you can update networks, because people may decide, I deploy a set of VMs with one particular network offering. And in that network offering, it uses VPX to be the router. But now they say the VPX is not performant enough, and I want to upgrade to the SRX firewall. And so in that case, then you update the network offering, and then you ask CloudStack to restart all of the networks. And the network CloudStack will shut down the previous network, update all of the technologies involved, and then restart using the new technologies, the new service providers. Excuse me. So restarting the network, it basically republishes the blueprint. And so that you made a change, and we will republish. And if you want to restart, we will republish every single rule back to all of the network elements that says, now this is the current set, and you should implement to this current set. And you can restart a network with cleanup, which means that you need to go back and delete what you had before, and we implement everything. And so, for example, if you have a VPX, you might want to actually delete the VPX and restart. Whereas if it was not cleaned up, then you just reprogram the VPX. Your VPX may be at a level of corruption that you can never reprogram it. So in that case, you just throw it away, start a new one, and program the new one. And we do things to protect against the end user doing stupid things. For example, an isolated guest network can only be deleted if no VMs are using those networks. And deleting the network will automatically clean up the resources we create to support that network. So for example, for virtual router, it will be deleted by the network element that implements the virtual router. We say, oh, this network needs to go away. The network element, we signal that to the network element. The network element says, oh, I have to remove the resources I've created to support that network. And public IPs will be released back into the IP pool. So now I want to go further into how you would actually implement a network element. Like I said, network element is an interface. is used by the network manager. In this case, this example is showing you how to program a DNS given a VM needs to be started. Right? The DNS service will implement the network element because it needs to be informed by about VM starting and its IP addresses. The DNS service is also an interface. This says I implement DNS for CloudStack, and this one right here is the actual implementation. So that my DNS element implements the DNS service, which then also implements the network elements. Network manager informs the network element. That comes down to, and of course that event comes down to my DNS element, which then talks to its actual implementation. This is the manager that manages DNSs in CloudStack. And then this manager is the one that actually talks to the resource, which then programs the actual DNS. Now, this manager would also need to have things in the API that allows people to program how to talk to that particular resource. For example, that DNS server may be at 4444. Sorry, a little bit cold here. Excuse me. So then, and this pluggable service would need to expose an API that says, well, I'll register the actual DNS with this manager, because you need to register that DNS. You probably have to register the authentication and with that manager to that DNS server, right? You might have some sort of configuration of how to propagate the DNS. So you have a lot of those type of questions. And so in order to program or register that and program the data that this guy needs, then you will have an API. And then you can actually configure it as a client and using that API that is exposed by the pluggable service. And this afternoon we're going to go into that a little bit more about how the actual writing of it. So then, and this manager may actually save things into the database, and then when it gets informed by its element, then it actually retrieves that information and says, oh, I need to go program it, and it sends that information back to its resource, which then programs the element, the actual element. Okay, so that's actually the slide. I do have a little bit to talk about more, because this is something that just came up right after I wrote this set of slides, and I wanted to kind of bring that to everybody's attention. Right after I wrote this set of slides, someone asked me, we have a set of rules, right? Network rules. Those network rules looks like, so let's say load balancing rules, right? A load balancing rule says this public IP goes to VM 1, 2, and 3. And it looks like we should be able to just say, it looks like a load balancing rule that you would actually put onto load balancer. So the person who was implementing this then asked me, well, why is this a virtual entity? Why is it a virtual entity controlled by CloudStack and not the actual physical load balancing rule that is inside the load balancer? So the problem with that is, if you are thinking only in terms of the load balancer, that's simple. Those two rules look exactly the same. Load balancer says public IP mapped to the following IP addresses. CloudStack says public IP mapped to these VMs. But what if it is not only implemented by the load balancer? What if you have an inline configuration of a firewall in front of the load balancer? What is the actual steps that happens? Well, the steps is you allocate an IP address to the load balancer. you set up a static NAT rule between the public IP address and the load balancer's IP address. So that's one extra rule. And then there is a rule to do the actual load balancer. So one load balancing rule in CloudStack maps into 2 actual rules in the physical world. And if you put those rules all into CloudStack's table, then the end user will see it. The end user will go, why is there suddenly a static NAT rule in my list of rules? And it would be, and the static NAT rule would actually be going to an IP address. He doesn't understand why it's there, because that is part of only the provision of the inline configuration. So in CloudStack, CloudStack's rules are all virtual entities, even though they look like physical entities, right? And they have to look like it because that's how people look at load balancing and IP addresses. But they are virtual entities, and then someone else has to implement the actual physical programming. And because you may not be the only load balancer in the system, and the network configuration may not be only have a load balancer directly to the public network. So those are things, I couldn't put it into the slide because it happened right after I wrote these. I didn't have much time. I'm not sure if that conveys. So I'm done with this slides. And we're pretty close to 12. Do you want, we can do the VR afterwards?
Do you have an SDN slide?
Oh yeah, there is an SDN slide.
Oh, Susan's posted.
Okay, yeah. Question?
多分お昼ご飯前に Q&A タイムを取りたいと思うので、そこで質問してもらってもいいですか？
あ、まだですか。
はい。まとめて覚えてください。
SDN expert. Deep in CloudStack is the expert. These are his slides. No, so if you have any questions, don't ask me. No, you can ask me. And just be aware that I'm an unknown. So this is a typical CloudStack deployment, right? You have the management server cluster in data center 1 backed up to data center 2, and it controls multiple availability zones. You can program physical network within one availability zone, and you can duplicate that across multiple zones. So I think in general you have seen this in our introduction and our architecture. So then what CloudStack does is overlay guest networks over this virtual network. So one particular user's VMs with its router and its storage using the same physical network. But they are overlaid and isolated, right, from a user 2's networks. So I was asked the questions about VLAN and VLAN's isolation and is tops out at 4K per data center. Now you can add another availability zone. And have another 4K, but then between availability zones you cannot communicate, or it has to go to edge and come back. So and it cannot stretch across multi-tier apps across data centers. So this is how AWS implements their VPCs. Right? They have the central router that routes between 2 different subnets, as in the VPC. And then so that's number 3 is where basically the DMZ for the end user is, right? And these are actual web app servers, and then it's controlled by the router. To reach the DB servers in a different subnet. So we wanted to implement this as using OVS, and what we're doing is we use the OpenFlow protocol. There's a For Sense Server, there's already a high performance production and quality replacement, and right, it replaces the Linux bridge code. And Sense Server 6.0 has already set that as the default networking stack. And so we program it using GRE terminals. And what CloudStack does is we replace the network group because the IP addressing scheme is different in this case. And then there's also a network element that gets signaled when the VM is about to start. And when that happens, then CloudStack will program the GRU terminals on the destination hosts. So for example, if there are 4 VMs in that particular network, then we will actively program the GRE tunnels on 4 different hosts so that they can all communicate with each other. So there is an embedded overflow controller. And for that, then when things such as live migration happen, then we will program correctly on the host that the VM is going to be on. And there are virtual router, same thing with the virtual router. So I think this is phase 1, we demoed it. Phase 2, we're looking to add KVM support, NetScaler VPX for load balancing and NAT, and then support for multi-hypervisor clouds. And I think there's a big switch is actually writing integration code for external controllers. And phase 3, we're planning to add VXLAN as an alternative to GRE. And then today we already have the VPC concept, but the VPC concept is completely on VNet, and we're expecting to implement the VPC concept on GRE. So that's very quickly what I know. If there's any questions, please ask. If I don't know how to answer them, I'll write them down and I'll make sure you guys get an answer.
When is the target of phase 2?
Yeah, I don't have that right now because a lot of the targeting stuff happen with our product managers. I don't have the information.
非常に面白い話だったんですけども、先ほど DNS の話出てきて、多分DHCP の話とか、バーチャライズされているネーミングの世界ですね、IT の管理とかネーミングの話が、要はバーチャルの世界の話と、フィジカルなところのマッピングの話っていうのが、多分いろいろオーケストレーションとプロビジョニングということで、いろいろ関係してくると思ってるんですけれども、疑問としましては、クラウドスタックはどこまでやるのかなというのがよくわからない。という逆に言いますと、我々はクラウドスタックを使うために外部でどこまで準備しなきゃいけないのかなというのがちょっと今日のお話ではよくわからなかったんですけども、その点でどういうふうに考えられているのかというところがちょっとお話できる範囲ですいません。
Do you mean in terms of network setup, or in terms of DNS setup or DHCP setup? When you say prepare?
いや、非常に、抽象的なレイヤーでまず考えたときにクラウドスタックの守備範囲とそれでない守備範囲、準備しなきゃいけない守備範囲というのがまずはっきりしないので、ちょっとそこのところをまずで、細かい設定の話は多分それは実際に作業としてやるときにやることなので、それは個々に解決してはいいと思うんですけども、今のブループリントを書くときのクラウドスタックのブループリントの話とその外部のブループリントの話がちょっとよくわからないんですけども、どうなんでしょう。
Okay, so I think you're asking how to prepare for a deployment of CloudStack. So in this case, you need to prepare your network. You first have to determine what type of network technology you're going to use. So let's say that you were using VLAN, and you're going to deploy layer 2 networking for your end users. Then you have to look at, I need to have switches that understands how to trunk VLAN and into hypervisors. That type of programming needs to be done by you, because CloudStack does not program the switches right now, and there's no plugins today to program the switches. But we do program on the hypervisor, so that if the VLAN arrives at the hypervisor, then we know to program the hypervisor to accept that and send it to the VM. So those things you do not need to figure out, but you do need to program the switches to make sure that your network environment is up.
じゃあとりあえず今 VLAN の話なんだけど、それをオープンフローでやろうとか、あと VXLAN でやろうとかってしたときには、そこのメニューはとりあえずクラウドスタック側のオーケストレーションとしてはなくて、それがこういうことができるよということだけで、あとはプラグインとしていろんなものを自分たちで準備してやってくださいという答えでよろしいですか。
Yes. So in 4.0, you can select technologies and says, I want to select OBS. Then that will use the OBS plugins because we already have the plugin available. Now, OBS plugin is not production level. It's only in prototype level right now. And we need to make a production level before you can use it in production environment. But for CloudStack, you don't actually have to write the implementation for OBS. You should be able to just select it that says, I want to use this technology.
もう一つ突っ込んで話すと、そのプラグイン自体はオープンソースとして書かれてるわけですから、自由にインターフェースが定義されてて作っていくことをだと思っててよろしいんですか。
Yes. Yeah. Everything that CloudStack has is open source, including OBS.
どうもありがとうございます。わかりました。
Thank you.
ここは質問ありますか。
この前のスライドのところでバーチャルルーターの再起動の時にクリーンアップのオプションが使えるという話の中でパブリック IP についてもリアプライという話が書いてあったんですけれども、これはプールしてあるパブリック IP の中からまた違う新しい IP が当てられることがあるという理解でよろしいですか。
No, because once the IP has been assigned, for cleanup, we're not in a restart of network and cleanup. We do not release the IP addresses. But when we destroy the network, when we say, oh, this network no longer should exist, that's when we actually release. Because we need to keep, because for the end user, the IP needs to stay constant because it's been acquired. I mean, they've already allocated for use. So when we restart and say cleanup, the same IPs gets reassigned back for its own purposes.
はい、わかりました。ありがとうございます。
Thank you.
すいません、ネットワーキング周りのスライドのところにあったMyDNS の実装って多分あれは単なる例で、実際にはリポジトリにはないと思うんですけど、ネットワーク周りのソースコードを読む上で一番最初にその簡単というかトリッキーなことをやってないようなその入門者向けのその内容というかものがコンポーネントがあれば教えてほしいなと思います。
That's a tough question. So for the CloudStack developer bootcamp back in made, I wrote a very beginner network element, and I can send that out to the list, and you guys can take a look at that. I mean, what that network element did was it just logged the event into a database, or actually into a file, but then that demonstrates where are the interception points for CloudStack and how to write more. And I can send that to the list. If you can remind Kimi, I'll do that. And actually, I plan on writing a similar one this afternoon when we do the actual coding. But in terms of existing code, it's generally very difficult because most of the code are complicated. They have to deal with technologies that you have to understand.
はい、ありがとうございます。非常に興味があります。読んでみたいです。ありがとうございます。
Thank you.
他はありますか？
すみません、先ほどバーチャルルーターでパフォーマンスが足りなくなったときはユーザーでアプライアンスジュニパーの SRX とかF5 に変える変えるって話あったんですけど、ユーザーはどうやってパフォーマンスが足りてきてないなっていうのを判断したらいいんでしょうか。
So normally what happens there is the end user is running some sort of a network bandwidth test inside the VM to verify that it can accept the traffic that they expect. And when they run that, they see that the virtual router is not enough. Then they need to request to the administrator that they want a higher offering, that they want a higher capacity offering. Now, the operator may not have the higher offering, and they have to add these F5 or SRX posts. But that's a negotiation between the end user and the operator.